thread by tilting the compound rest method.
Materials and equipment. Lathe machine. Cutting tools. Tapping tools. Thread grinding machine. Grinding wheels. Calipers or micrometers. Process 1. Hold the job in 4-jaw independent chuck and through the job. Turn diameter 40 mm for possible length. Knurl on diameter 40 mm and chamfer the edge 1 into 45. Reverse and hold on knurl diameter and through the job. Center drill the end. Finish turn diameter 32 mm for 130 mm. Step turn to 25 mm for a length of 20 mm. Form the radius groove for 7 mm width and maintain diameter 25 mm. Chamfer the end to 1 into 45 degree chamfer threaded end to 3 into 30 degree. Arrange the gear train for 5 mm pitch thread. Hold the Acme thread cutting tool in the tool post to center height. Cut external Acme thread. Check the thread formation. Acme thread cutting, female. Process 1. Hold the job face the ends to length, turn diameter 40 mm and chamfer the ends. Knurl on diameter 40 mm. Drill and bore the hole to the core diameter of the thread by supplying coolant to the job. Cut internal Acme threads and match. Chamfer 3 into 45 degree at both the ends of the nut. Hold the assembled male and female jobs between the chuck and the center. Process 2. The workpiece should be properly mounted and finish turned to the major thread diameter. The tool should be correctly set and the compound rest swivel to the right at an angle of 14 degrees to the normal. The offset angle of 14 degrees makes the tool feed into the work at an angle. Because of the offset angle, most of the stock is removed by the left side of the tool. The chip also curls out of the way to the left. The right side of the threading tool shaves the newly cut threads smoothly. Grind Acme thread tool for the required thread angle and pitch. 29 degree, 4 mm pitch. Clamp the tool in the tool post to the center height and align with the center gauge with minimum overhang. Ensure that the tool is set to the center height. Check the diameter of the workpiece to be threaded by referring to the working drawing.
In this video, we learn about how to cut and match internal and external single start Acme thread and how to cut Acme thread by tilting the compound rest method. I hope you have understood all the concepts and exercises. In our next video, we will bring you another wonderful concept. Till then, take care. Hello students, welcome to the topic of fitting of male and female threaded components. At the end of this exercise, you shall be able to assemble the Acme thread and inspect the assembly.
Materials and equipment. Wrenches or spanners. Threaded fasteners. Tapping tools. Thread gauges. Calipers or micrometers. Process. Clean the external and internal Acme threaded job. Check thread dimension, pitch and thread profile. Hold the male job in vertical position using bench vise and packing piece. Tighten the female threaded component by rotating clockwise direction onto the male threaded component.
In this video, we learn about how to assemble the Acme thread and how to inspect the assembly. I hope you have understood all the concepts and exercises. In our next video, we will bring you another wonderful concept. Till then, take care. Hello students, welcome to the topic of cut Acme thread over 25 mm diameter rod and within length of 100 mm. At the end of this exercise, you shall be able to set the job in between chuck and center cut external Acme thread.
Materials and equipment. Large lathe. Lead screw. Acme thread cutting tool. Threading die. Calipers or micrometers. Process. Hold the job in 4-jaw independent chuck and through. Set the tool to the correct center height. Face one end of the job. Turn diameter 36 mm for possible length. Chamfer the end to by 45 degrees. Reverse and hold the job. Finish to a total length of 160 mm. Center drill the end. Hold the job between the chuck and the center. Turn 25 mm to a length of 128 mm. Turn step diameter 20 mm to a length of 20 mm. Form an undercut with 8 mm between the head and threaded portion of the job. Chamfer to by 45 degrees and 3 by 45 degrees. Hold the Acme threading tool in the tool post to its correct position. Cut external Acme thread. Check the thread formation.
In this video, we learn about how to set the job in between chuck and center and how to cut external Acme thread. I hope you have understood all the concepts and exercises. In our next video, we will bring you another wonderful concept. Till then, take care. Hello students, welcome to the topic of buttress threads cutting male and female with tool grinding. At the end of this exercise, you shall be able to set buttress threading tool, cut external and internal buttress threads, fitting male and female threading parts.
Materials and equipment. Lathe machine. Thread cutting tools or tapping tools. Tapping tools. Grinding machine. Grinding wheels. Calipers or micrometers. Cutting fluids. Process. Task 1. Making buttress male component. Hold and through the job in a 4-jaw chuck. Turn diameter 48 mm for possible length. Again turn diameter 40 mm up to a length of 95 mm from front end of the job. Make a step of diameter 25 for a length of 25 mm. By using parting tool, make the diameter 34 mm multiply by 5 mm step. Make use of buttress thread cutting. External tool, cut the required thread to a length of 70 mm. Check the thread for its measurement and accuracy. Task 2. Making buttress female component. Hold the job, face the ends to length and turn diameter 48 mm, chamfer the ends. Drill 14 mm diameter and bore it up to 32.3 mm to a length of 65 mm or more. Fix the internal buttress thread cutting tool and cut to the required thread after setting the change gear train. Check the accuracy of the thread. Task 3. Grinding for buttress thread tool, male. Remove the excess material on the right-hand side to the required width and length by using a rough grinding wheel. Grind a front clearance angle of 6 degrees and end cutting edge angle of 6 degrees. Check with a protractor and maintain an accuracy of ±10_. Grind RH side relief angle of 1 degree and a side clearance angle of 2 degrees. Grind LH side relief angle of 1 degree and a side clearance angle of 2 degrees. Grind to a top rake angle of 6 degrees and form angle of 45 degrees. Task 4. Grinding for buttress thread, female. Prepare the pedestal grinder for grinding our internal buttress threading tool. Grind bottom clearance angle of 30 degrees to 45 degrees and end cutting angle of 10 degrees. Grind a side clearance angle of 8 degrees and a side cutting edge angle of 20 degrees. Grind a top rake angle of 10 degrees and a side rake angle of 40_. Maintain a nose radius of 0.3 to 0.5 millimeters. Deburr with an allstone and check the tool profile with a tool angle gauge protractor. Points to remember. Avoid burning of tools. Make sure the cutting edge is visible always. While grinding, make use of the entire width of the grinding wheel, that is, don't grind in one particular place.
In this video, we learn about how to set buttress threading tool, how to cut external and internal buttress threads, and about fitting of male and female threading parts. I hope you have understood all the concepts and exercises. In our next video, we will bring you another wonderful concept. Till then, take care.
Hello everyone and welcome to this module on the plumbing trade. In today's video, we are going to identify the tools and equipment used in masonry work. By the end of this lesson, you will be able to identify and understand the hand tools that are used in masonry. Identifying tools used in masonry and understanding their uses. The straight edge. The straight edge, though seemingly simple, is a multifunctional tool in a mason's toolkit. While checking squareness is its primary function, it offers a surprising range of uses throughout the construction process, like assessing the flatness of surfaces and leveling and removing excess plastering. When using a straight edge in masonry work, precaution should be taken to ensure safety, accuracy, and efficiency. Inspect the straight edge for any defects, bends, or damage that could affect its accuracy. The spirit level. Spirit levels are indispensable tools in masonry work, offering precise measurements and ensuring accuracy in various tasks. Some functionalities of spirit levels include checking surfaces for slopes and checking surfaces for flatness or uniform level. When using a spirit level in masonry work, precaution should be taken to ensure safety, accuracy, and efficiency. Avoid dropping or mishandling the level, especially if it is made of fragile materials such as glass. The boat level. Boat levels are compact and easy to use and play a vital role in the mason's work for various tasks related to levelness and alignment. Some functionalities of boat levels include checking for flatness or uniform level of plumbing fittings after being laid, checking surfaces for slopes, and checking the flatness or uniform level of bricks after being laid. When using a boat level in masonry work, precaution should be taken to ensure safety, accuracy, and efficiency. Avoid using the level on surfaces that are uneven, sloped, or soft, as this can affect the accuracy of the measurements. Plumb bob. The plumb bob, also known as a plummet, is a simple yet essential tool in a mason's toolkit. It plays a crucial role in ensuring vertical accuracy throughout the construction process. Some functionalities of the plumb bob include checking the vertical accuracy of bricks after being laid and checking the vertical alignment of walls. When using a plumb bob in masonry work, precaution should be taken to ensure safety, accuracy, and efficiency. Ensure that the weight is securely attached to the string. Plumb rule. A plumb rule tool, also known as a plumb line, is a tool used to determine a vertical plane. Plumb rule tools are used to measure the depth of wells and shafts and checking the vertical alignment of walls. When using a plumb rule in masonry work, precaution should be taken to ensure safety, accuracy, and efficiency. Ensure that the surface on which it is placed is level. Block trowel. A block trowel, also known as a mason's trowel, is a specifically designed tool for spreading mortar on bricks and concrete blocks. Some of the functionalities of the block trowel include scooping and spreading mortar evenly, ensuring that the brick adheres properly to the mortar bed, removing excess mortar, and cutting blocks to fit tight spaces. When using a block trowel in masonry work, precaution should be taken to ensure safety, accuracy, and efficiency. Be mindful of the sharp edges of the trowel blade to prevent accidental cuts or injuries. Jointing board. A jointing board is a valuable masonry tool designed to prevent mortar from dropping during the construction process. To fill the seams between the bricks, spread mortar evenly, and prevent mortar from dropping. When using a jointing board in masonry work, precaution should be taken to ensure safety, accuracy, and efficiency. Avoid overloading the jointing board with mortar, as this can make it difficult to control and may result in uneven surfaces. Steel square. The steel square, a crucial tool in masonry work, serves several purposes. It ensures corners make perfect 90-degree angles, and it guides precision cutting for bricks and blocks. When using a steel square in masonry work, Precaution should be taken to ensure safety, accuracy, and efficiency. Inspect the steel square for any defects, bends, or damage that could affect its accuracy. Gauge rod or rule. The gauge rule is a fundamental tool in masonry work, offering versatility and precision in various tasks. It is often used to check the thickness of walls and to check the sill level and spring level. When using a gauge rule in masonry work, precaution should be taken to ensure safety, accuracy, and efficiency. Avoid dropping or mishandling the rule to prevent damage to the edges or markings. Lines and pins. In masonry work, lines and pins are essential tools for achieving accuracy, alignment, and proper layout. It is often used as a visual guide to align bricks or blocks and used as a guide to construct well-aligned walls. When using a line and pin in masonry work, precaution should be taken to ensure safety, accuracy, and efficiency. Ensure that the line is strong and durable and that the pins are straight and free from bends or breaks. Corner blocks. Wooden corner blocks are frequently utilized in masonry work for several purposes. These include ensuring that the corners of the buildings are properly aligned and used as a guide to support vulnerable joints. When using a corner block in masonry work, precaution should be taken to ensure safety, accuracy, and efficiency. Avoid dropping or mishandling the blocks. Tingle plate. A tingle plate is a small metal plate used in masonry work to prevent lines from sagging. It is used to correct the sagging of a line. When using a tingle plate in masonry work, precaution should be taken to ensure safety, accuracy, and efficiency. Remove any excess mortar or grout immediately to prevent staining or corrosion. Bolsters. Bolsters are used in masonry work for a variety of purposes, including cutting bricks and slicing mortar beds. When using a bolster in masonry work, precaution should be taken to ensure safety, accuracy, and efficiency. Always strike the bolster away from your body to prevent accidental injuries. Club hammer. Club hammers have a short handle and small head and are usually used along with a bolster to cut bricks and help remove mortar from joints. When using a club hammer in masonry work, precaution should be taken to ensure safety, accuracy, and efficiency. Position your hands away from the striking zone to avoid accidental contact with the hammerhead. Scutch. A scutch hammer is a tool used in masonry work for cutting bricks, removing mortar, and dressing bricks. It is used to trim or cut a brick or a block and to remove old or excess mortar from brick surfaces. When using a scutch hammer in masonry work, precaution should be taken to ensure safety, accuracy, and efficiency. Avoid swinging the hammer too forcefully, as this can lead to inaccurate strikes. In this video, we have discussed how to identify and understand hand tools used in masonry. Hope you have a clear understanding of this session. Thank you all and see you again in the next video. Hello everyone and welcome to this module on the plumbing trade. In today's session, we are going to learn to set out work with the tape, rule, square, line pin and level as per the drawing. By the end of this lesson, you will be able to mark the third line of the building, mark the fourth line of the building, drive nails on pegs, verify the diagonal distance between profile markings. The required materials and tools are builder's square steel 75 cm by 50 cm 1, nylon marking thread as required, a hammer mason or club 1.5 pounds 1, measuring tape 30 meters 1, plumb bob 1, steel tri-square 1, spirit level 1, 35 mm long and wire nails as required, wooden pegs as required, wooden profiles as required, lime powder as required. Let us now start the procedure. Mark the third line of the building. Measure an arbitrary distance of 1 meter from the boundary DC. Locate pins P5 and P6 to encompass the overall dimensions of the rear side of the building, including the foundation excavation width and a safe distance. While measuring, stretch and hold the steel tape without a sag and as low as possible, clearly above the ground and truly horizontal to the ground. Drive pegs at points P5 and P6. Drive the nail on the center of the peg P5 and tie a line thread. Stretch the line thread at right angles using the builder's square to line P3, P4 and to appear on the peg at P6. Locate the nail point on peg P6 and drive a nail so as to be at the center of the line thread. Tie the line thread on the nail in peg P6 and obtain the third line P5, P6 at right angles to line P3, P4 and parallel to the lines P1, P2. The next task is to mark the fourth line of the building. Measure an arbitrary distance of 1 meter from the boundary CB. Locate points P7 and P8 to encompass the overall dimensions of the right side of the building, including the foundation excavation width and a safe distance. Drive pegs at points P7 and P8. Drive a nail on the center of peg P7 and tie a line thread. Stretch the line thread at right angles using the builder's square to line P5, P8 and to appear on the peg at P8. Locate the nail point on peg P8 and drive a nail so as to be at the center of the line thread. Tie the line thread on the nail in peg P8 and obtain the fourth line P7, P8 at right angles to line P5, P6 and a parallel to the line P3, P4. Measure the diagonal distance between intersection points E and H. Measure the diagonal distance between intersection points G and F. All the line threads must travel at the same level and separated only by thickness of the threads. Use builder's square to turn and check the back right angle of the thread line. Let us now learn in detail how to drive nails into pegs. Mark with a pencil the approximate center point of the flat surface of the driven peg. Hold the nail vertical with the sharp point on the center mark. Strike the nail head gently with the claw hammer. Let us now learn to verify the diagonal distance between profile markings. Tie thread lines between profiles to run on the center line mark. Obtain intersection points on the line thus stretched. Measure the distance between diagonally opposite intersection points. The distance between two such pairs should be equal. Let us now learn in detail how to set out a building, marking the center line layout of the building. This task will help you produce center lines of the building on the profiles and transfer center line marks on the ground. Trace the center line plan of the building and orientation of the building. Tie all line threads at the same level. Level separated only by thread thickness between pegs P1, P2, P3, P4, P5, P6 and P7, P8. Calculate half the wall width, that is 115 mm, plus the balance 2 meter of 2115 mm for locating the center line pegs for the front wall of the building. Measure the distance of 2115 mm on the line thread P3, P4 from the intersection point E and locate the drive peg P9. Repeat the process from the inspection point F and locate peg P10 and drive the nail. Now tie a line thread between P9 and P10. Mark a safe distance, say half a meter in front of peg P9 towards the building and drive a profile. Repeat the same procedure in front of peg P10 and drive another profile. Mark the center line on these profiles. Remove line thread P9, P10 and tie between these two profiles and obtain the center line of the building front wall. Repeat this process to obtain all other center lines as per the center line drawing. In this video, we have discussed how to mark the third line of the building, mark the fourth line of the building, drive nails on pegs, and verify the diagonal distance between profile markings. Hope you have a clear understanding of this session. Thank you all and see you again in the next video. Hello everyone and welcome to this module on the plumbing trade. In today's video, we are going to prepare cement mortars and RCC in different proportions to suit various purposes and carry out damp proofing. By the end of this lesson, you will be able to prepare mortar ingredients for a specific mix, mix mortar manually, follow appropriate safety precautions, repair damaged portions of walls, ceilings and roofs, repair dampness of floors and repair the sink bed. First, we are going to prepare cement mortars and RCC in different proportions to suit various purposes. For this, the required materials and tools are spade 1, bucket 1, mug 1, measuring box 1, mortar pan 1, mason trowel 1, GI sheets for the platform 1, cement 1 bag, sand 5 bags, water as required. Let us now start the procedure. Level the area where mixing is to be done. Place adequate number of GI sheets on the leveled ground. Bring the required quantity of sand and water near the mixing area. Measure sand using the measuring box and pour into a heap. Transport the cement bag and place it on the heap of sand. Cut open the cement bag, pour and spread the cement evenly on the sand. Important precautions to be taken during this process. Always wear a dust mask. Cutting cement bags without damaging the bag is essential to prevent spillage and ensure efficient handling of the cement. Use a spade to dry mix the contents until a uniform color is achieved, indicating that the ingredients have been mixed properly. Add sufficient quantity of water as per the water-cement ratio to ensure the right consistency of mortar. Mix quickly to ensure that the water does not flow outside the heap. Pour the remaining quantity of water using a mug and continue to mix simultaneously. Do not use a curing pipe to add water. Keep mixing until the consistency of the mortar is uniform. Pouring extra water will dilute the mix. Use the mortar within 30 minutes of mixing. Let us now use a measuring box to measure ingredients. Bring the measuring box closer to the work area. Fill the measuring box using a mortar pan. Once the box is filled, use a trowel to remove any excess sand. Let us now learn to mix the cement mortar. Mix the mortar using the watertight platform. Use an MS tray for smaller quantities and a GI sheet for larger quantities. Mix the required quantity of sand and cement by turning them over from one end to another end and cutting with a shovel until the mix appears uniform in color. Mix the dry ingredients by turning them in opposite directions to ensure that it is well blended. Then form a heap. Create a gap in the middle of the heap. Add the required quantity of water using a mug while continuing to mix. Ensure to add water according to the water-cement ratio. The same procedure should be followed to prepare plain concrete and RCC. Coarse aggregates should be added during the preparation of concrete. The RCC or reinforced cement concrete mix ratio depends on the structural requirements and specifications of the project. However, a common mix ratio for RCC is 1:2:4, which means 1 part cement, 2 parts fine aggregates such as sand and 4 parts coarse aggregates like gravel or crushed stone. Let us now learn about damp proofing. By the end of this task, you will be able to repair damaged portions of walls, ceilings and roofs, repair dampness of floors and repair the sink bed. For this, the required tools and materials are jointers 1, hammer ball peen 1, wooden float 1, mortar pan 1, mason trowel 1, cold chisel flat 1, straight edge 1, spirit level 1, chipping hammer 1, cement as required, sand as required, aggregate as required, asphalt as required, aluminium sheet as required, copper sheet as required, lead sheet as required, bituminous felts as required, and MS rod as required. Let us now look at damp proofing. Select proper hand tools and materials required for this work. Inspect door frames, windows, sanitary joints and the rainwater outlet. Wall cracks should be properly plastered using rich cement mortar. Damaged portions of bathroom pipe joints should be identified. Damaged pipes should be repaired by fixing the leaks and repacking them using appropriate materials. To prevent water seepage on the terrace, the damp portions should be clipped. After applying dry rich mortar, the waterproofing compound should be used to plaster the area and the level should be checked. Rusted or damaged pipes or joints should be removed and replaced with new pipes or joints. Leakages in the kitchen sink, wash basin, washing machine, bathtub and outlet drains should be identified. These leakages should be fixed by replacing the equipment or by using white cement. Cracks in overhead RCC water tanks should be inspected and a small piece of iron rod should be placed in these cracks. Rich cement mortar and waterproofing compound should be used for plastering these cracked portions. Remove old white cement from the joints in the sanitary fittings. New white cement should be applied to the joints in sanitary fittings. Concealed water pipeline leakages should be identified. Replace the new pipelines and plaster using rich cement mortar. Inspect bathroom floor tiles, toilet floor tiles to identify leakage. Replace broken tiles by replacing new tiles and plaster joints using asphalt, aquaproof and white cement. In this video, we have discussed how to prepare mortar ingredients for a specific mix, mix mortar manually, follow appropriate safety precautions, repair damaged portions of walls, ceilings and roofs, repair dampness of floors and repair the sink bed. Hope you have a clear understanding of this session. Thank you all and see you again in the next video.
Hello viewers, welcome to DigiShala. I am Rajalakshmi, Training Manager working at National Institute of Rural Development and Panchayati Raj, Hyderabad. Today we will discuss some of the queries we got from all over the country on different modes of digital payments. I have here with me Dr. Anuradha, Assistant Professor from NIRD and PR, to give her expert take on subject.